Hello, good morning, and welcome to our sixth session of Girls Make IT Better. Today we are joined by Andy Janik, who's a software developer lead in the Treasury Services Department here at the Cleveland Federal Reserve Bank. Today, Andy will be telling us about his career path as well as his job here at the Fed, and then after that, he'll be leading us through a hands-on activity on computer programming and encryption. After we do that hands-on activity and hear a bit more about Andy, we will be moving on to our Kahoot quiz as we end every event. In our Kahoot quiz, we will have an opportunity to do a Q&A with Andy, where there will be some pre-written questions that you guys can pick from to ask Andy. But if you have any personalized questions that you'd like to ask Andy, anything that you might have heard during his presentation or anything that intrigues you about his career path, feel free to put those in the chat box and you'll be able to ask that during that Kahoot portion of our today's session. But without further ado, I'm going to go ahead and hand it over to our guest today. Andy, go ahead.
Hello, everyone. So I'm going to go ahead and share and get started my presentation. All right, so today we're going to go over a variety of things. So I'm just going to start off with the agenda. First, we're going to talk a little bit about me and my career path and how I got to be here at the Fed. Then we're going to talk about a web development framework called Angular. We're going to talk about style guides and the United States web design system that we use here at the Fed. And then we're also going to talk about encryption. So that's a really important thing in web development. At the Fed here, I've worked on the pay.gov website, which is how a majority of the government agencies take payments. So encryption is very important when you're dealing with people's credit card information and their passwords. So we're going to do a hands-on example after we learn a little bit about encryption. That hands-on will be on Blitz, which is an online development platform that makes it really easy to develop applications in a variety of languages. And then we'll wrap things up. So let's start the about me by taking a trip back in time. So we're going to go back in time about 25 years. And that was the beginning of my senior year in high school. And at my high school, I had this wonderful senior picture. And we also had to, in our yearbook, say what our plans were. So this is actually from my yearbook. I took a picture of it. My plans were to attend college and attain a master's degree in computer science / engineering. So the reason I bring that up is I wrote this in the beginning of my senior year. And at that time, I didn't even really know what computer science was. I had taken some computer programming classes. I had a graphing calculator, so I had wrote some programs on there, including a duck hunt game. And again, this is 25 years ago. So I knew I liked programming, and I assumed that I would do something with computers if and when I made it to college. But I didn't really know what computer science was. So what computer science is really the study of computers, obviously, and any kind of computational system. But it mostly deals with the software. So writing software, designing software, implementing software, and the theory behind all kinds of different software applications. So again, there are many jobs in computer science, many fields in computer science, but programming is one of them. That's what I do now. There's architecture, which is kind of designing how applications work. There's user interface research. There's user interface design for web applications. There's artificial intelligence research and design. There are a variety of things that you can do in computer science. And again, 17-year-old me wasn't quite sure of that. I just knew that I liked to program. So did I actually become a computer science and get that master's degree that I thought I would do at 17? Well, eventually I did, but we're going to take a step through what actually happened because you'll find a lot of times career paths are not straight lines, right? So I started off going to community college when I graduated high school. I went to Lakeland on the east side. And then I ended up at Kent State. So when I was at Kent State, I decided to change majors. I was not going to be a computer scientist anymore. I was going to be a high school math teacher. I had a really great high school math teacher that senior year, and that completely changed my plans. So I decided to become a high school math teacher. I went to Kent State. I ended up graduating, and I did teach high school for 2 years. And then I taught middle school for another year. So I taught for 3 years after college. It was a great experience. It was the hardest job I've ever had. And then in the school district I was teaching in, they had some budgetary issues, and I ended up getting laid off due to levies failing. So at that point, I was looking around, and I could continue teaching, or I had this idea in the back of my head to get into IT, to get back into computers. So I did that. I ended up becoming a software tester. So I went to Nationwide Insurance, and for 4 years I was a software tester. So I wrote test plans, I worked on the website, I made sure the website worked the way that it was expected before we delivered it to customers. And I worked my way up to a software testing lead. So I had a small team that I worked with, and we tested applications front to back. And I did that all together for about 6 years. And then I got the programming bug. So the programming itch came back, going back to high school when I liked programming, and I was like, I don't want to test the software necessarily. I like to write the software. So I ended up going back to school. So I went back to Lakeland again a second time, and I studied programming. So I was doing that while I was testing software, and I ended up getting a certificate in enterprise programming, and I got hired at Nationwide to become a software developer. So here I'm really starting to fall into that computer scientist role. So I'm a software developer, I'm working at Nationwide, and I can go back to school again. So I went to Cleveland State this time, and I ended up getting a master's degree in computer science. It took me a long time, 6 years, but I did that while I was working. And as I'm doing that, I worked at Nationwide, and then I ended up getting a new job here at the Federal Reserve, and that was about 5 years ago. And so over the course of these 8 years, I'm working on my master's. I ended up finishing my master's about a year ago. And now I am a software development lead. So what that means is, again, I have a small team underneath me of a few developers and a few testers, and we build certain parts of the application. So basically, the reason I walked through this is to show that two things. One, your career path can take forks, and even though I ended up where I initially thought I would be at age 17, it took me basically 25 years to get there, and I taught in there, I did testing in there. And also you can see that learning doesn't stop when you get out of high school or get out of college the first time. I went back to school multiple times just to continue my career. So that leads me to talk about development. So now we're going to talk about Angular. So you might have heard of Angular. Angular is a really popular way to build web applications or websites. So roughly 26% of websites, public websites, use it. Some popular ones are Gmail is built with it. The PayPal website is built with it. Xbox.com, NBA.com, and a variety of others. And we use that here at the Fed on some of our websites as well. Now, the reason it's so popular is, one, it's open source, so it's free to use. And number two is it's supported by Google. So what that means is Google is putting resources into the development and the maintaining of the framework. So since it's supported by Google and it's also free to use, it has become very popular. It does a really good job of organizing code into what they call modules, so you can kind of think of those as buckets. So similar code goes into similar buckets, and it helps keep it organized and maintainable. Another really popular piece of it is two-way data binding, which we'll show in the hands-on. And its architecture is what's called MVVM. So what that means is the model talks to the view, or the view talks to the model, and we'll talk about that in the hands-on again. So again, Angular, really popular. I used it at Nationwide, and it was part of the reason that I came to the Fed, because they had started using Angular, and I really like the Angular programming framework. So it was a reason I ended up working at the Fed. So when you're doing web development, you're going to use a framework for the logic like Angular. Other popular frameworks are React or Vue, but you're also going to use a style guide a lot of times in the industry. So what style guides are kind of standards for the visual interface, like the way the website looks. So how it looks, how it functions. Most companies or most organizations that build a website, they are going to provide some kind of style guide, or they're going to develop a style guide, or they're going to use a style guide that is available to them. So there are popular style guides. Bootstrap is a really popular one. If you've ever used Twitter, the website for twitter.com, that was one of the early websites that used Bootstrap. Bootstrap styling is all over the web. Another popular one is Material. So Material is something that's very flat and it has sharp corners. If you use mobile apps like the Google mobile apps, they use the Material design. And then another more up-and-coming one is something called Pure CSS. That's really easy to make your own styling guides out of, and it's becoming more and more popular. At the Fed, we use something called USWDS, right? So this is the United States Web Design System. And it was actually developed by a government agency, the GSA, which is the General Services Agency. And it was basically built as a style guide that all government websites could use instead of everyone having to develop their own. So it's easier to use one that is centrally developed and maintained, and a lot of websites use it. Vote.gov uses it. Pay.gov, which is a website I have worked on, uses it. The NASA Glenn Research Center, which is here in Cleveland near the airport, their website uses it, and it's becoming more and more popular. So we're going to use a little bit of that. I'm going to show how to use that in the hands-on as well. So again, whenever you're doing web development, if you work for any kind of company, they're typically going to give you a style guide, so you have to become familiar with using their styles and how to implement them. So that's the framework we're going to use for the hands-on is Angular. We're going to use USWDS, the style guide. And what we're going to do is some encryption. So what you might be asking, what is encryption? So encryption is really a way to encode information. So you're going to take some kind of message that's in plain text, and you're going to encode it into what is called ciphertext. So this is the encoded message. The word for that is ciphertext. And really, the reason you're doing that is you want to deny the understanding of that plain text content by anyone who would intercept it or steal it. So this has been around since the ancient times, basically a way to communicate without people understanding. The only people who want to know it are the sender and the receiver. So encryption always uses either a single key or multiple keys and some kind of algorithm. So the message is going to get run through an algorithm using a key, and it's going to get encoded into ciphertext, get transferred in that ciphertext, and then at the other end, someone's going to decode it. So the whole point here is that it's easy to code as long as you have the key or the keys. Now, most encryption it is possible to actually break that encryption. So you might have heard the term brute force. That is simply trying every possible combination of characters in order to find out what that message is, that ciphertext message is. But usually it takes so much computer resources and really highly skilled people that it's not worth the time to actually break those messages. So most encryption can be broken, but it takes so long to do that it's not worth it. So there's a few types of encryption. So there's what's called symmetric key encryption. So that means that there is one key, and that key both encrypts and decrypts the method. And in this case, if you're using symmetric key, both the sender of the message that encrypts it and the receiver of the message needs to have that key. There's public key encryption. So this differs a little bit, is that the sender knows that the receiver, that person knows the public key of the receiver. So everyone can know the public key. So that means that key is publicly available. It runs it through the algorithm. The message gets encoded or encrypted. But the receiver has a private key that only they know, and that's how they unencrypt it or decrypt it. So there's really two keys here, and the receiver is the only one who knows the private key. So that's a little more secure than symmetric key, where both parties have to actually know the private key. And then the last is what is called hashing or hash functions. So that takes that text message and turns it into a hash value, and that hash value can be compared, and we'll talk about that more in the hands-on. It can be compared to itself to see if the message was the same. So that the benefits of hash are that it's quick, consistent, and it's almost infeasible to reverse the hash functions because there's no keys. So we're going to focus on two of those three, and the first one we're going to look at again is the symmetric key. So again, the key is the same for encrypting and decrypting. And some examples of that are the Caesar shift, which we're going to do in the hands-on. AES, which is an advanced encryption standard, which was developed by the government in the early 2000s. So we're going to look at that in the hands-on as well. DES, which is the data encryption standard. All of these standards that are used in the modern days are developed by organizations, and they're really, really hard to break. But as they get broken, they develop new layers or new versions of them that are more hard to break. So they're constantly iterating on these encryption standards to keep up from people who are breaking them. And some of the uses of this two-way encryption, sending PII. So that's something that we talk about a lot in the payment industry, which is personally identifiable information. So you want to think birth dates, social security numbers, addresses, stuff like that. A lot of times we will encrypt that information as we send it from one website to another website. That way anyone in the middle cannot grab that information or intercept that information and easily read it. You can also use it to validate that the sender of the message is a legitimate partner of yours. If you both have to have the key and someone sends you an encrypted message, they would have to have had the right key for you to decrypt it. So as long as that way you can verify you both have the same key. So pros to this two-way encryption is that it's fast because both parties know the key and the algorithm. Some of the cons, it's actually the same idea. Again, both parties need the key. How do I store that key? Is it written on a piece of paper? Do I store it in plain text on a notepad or in a database? Well, then it becomes easily hackable. So since both parties have to have the key, that is also a con. The other one we're going to talk about is hashing. So this is used pretty often in web development. And again, this is the one-way function to encode a given message into a hash value. So examples of this, we're going to look at SHA, which is the secure hash algorithms, and that we're going to look at that in the hands-on. And there's some others like RIPE-MD, And there's, again, a bunch of bodies, just they keep track of these algorithms, and if they get broken, they iterate on them and make them stronger. So a big use of hashing is passwords and other stuff that are being stored in the database, other PII. So the interesting thing about hashing is the same message always hashes to the same value. So your password, if you log into a website, should not ever be stored in the database as you typed it in. It should be hashed. And then what the website does is when you type it in the second time to log in, it hashes that again and compares it to the hashed value in the website. So the same password should hash to the same value every time, and that's how they tell that you've entered in the right password. They're not comparing your password to itself. They're comparing the hash of your password to the hash stored in the database. So again, pros of this, the same message is always the same hash value. It's very quick. It's almost infeasible to actually break it because there's no key. And different messages never get the same hash value. So now we're going to switch over to the hands-on, but we're going to review some programming stuff first. So the first thing I want to review is JavaScript and some of the data types that we're going to experience. So the main one we're going to use is an array. So an array is a comma-separated list of values. So here I have an array called my array, and it has A, B, and C. The length of that array is 3 because there's 3 values in there. And the interesting thing about arrays that you want to keep track of is that the first value in the array is actually indexed at 0. So the indexes are 0, 1, and 2. So even though the length is 3, the first value in the array is always at 0. We're also going to use numbers and strings. Those should be pretty self-explanatory. And first thing we're going to do is the Caesar shift. So the Caesar shift is named after Julius Caesar. He was a Roman general and statesman back around 55 BC. And the way he encoded his message or encrypted his messages is he would take each letter of his message and it would be replaced by some letter a number of places down the alphabet. So that number that he would shift was the key. He always used 3 as his key. So the letter A becomes D in the encrypted message. So one thing I want you to think about when we get to the hands-on is if the alphabet has 26 letters, how many possible keys would there be? So we're going to jump over to the project now. So I'm going to get out of the presentation.
And we have placed that link for Stack Blitz in the chat if you'd like to access it from the chat so you can follow along with what Andy's presenting on his screen.
Right. So if you open up that Stack Blitz, what you would want to do is you'll notice that the code is all here, but it's commented out. If you click the fork button, it is going to make a copy of this that now you can edit. So I just made a copy of my own, and you'll see that we don't really have anything on the right because everything's copied or commented out, but now we're going to start working on it. So the first thing we're going to uncomment out is you want to open up app.component.html. And if you think back to the architecture I talked about where it was model view and view model, this app.component.ts is the model and app.component.html is the view. So this is the model, this is the view. So that's the architecture, model and view. So the first thing I'm going to do is I'm going to uncomment out step 1.1. So I'm going to get rid of in front of this H3 and after this H4. Okay. So on the right hand side you should see now these 3 headings. So you see Caesar shift, the alphabet array, and the Caesar shift keys. Now this is the power of Angular. You'll see here that there are little brackets. this is the data binding that I'm talking about. So these are variables in the model, the alphabet array and the Caesar shift key. We haven't actually defined these variables yet, so you'll notice that there's no text here. If we go back to the model, so we're going to open up app.component.ts. When you scroll up to the top, you'll see in step 1.2, we're going to uncomment out lines 11 through 14. So when I do that, and the fast way to do that is to highlight it and hit Control/, or you can just delete the double slashes. You'll see here, now my two arrays are defined and they're showing on the screen because now they're bound from the model, this is the model, to the view. So now they're displaying what our alphabet array is and our Caesar shift keys. So now let's look at how we're going to encode a message. So step 1.3, we're going to uncomment out all the way down to line 30, actually line 31. So from 11 to 31. And when you do that correctly, you will see you should have an input field and a drop-down box. So we're going to look at a couple things here. First is I want to go back to that conversation about a style guide. So you'll see here that on my label, I have this class USA label. And you'll see here on my input, I have this class USA input. That is how I implement that USWDS style guide. So if I were to delete this class, you'll see that the styling changes for the input box. Now this is just a basic HTML input box. If I undo that and put that style class back, this is the way that USWDS wants their inputs to look. And you can see it over here. This is their documentation. And if we look up their components and we're using their text input, you'll see here that this is what they want the text input to look like. They've said use the USA input class, which I did, and the USA label class. So that's how you implement a style guide, right? A lot of times it's going to be with CSS classes in your view. So here I have an input box, and here I have a drop-down full of Caesar shift keys. To go back to the question I asked in the presentation, because there are 26 letters in the alphabet, there are 25 possible shifts. Obviously, if you shifted 26 times, you would just be back to the beginning of the alphabet. So now let's look at actually encoding our message. So let's go back to the model, which is an app.component.ts. And we're going to uncomment out line 17 through 19. Again, Control/, we'll do it all at once. So here I'm setting the default Caesar shift key to 0, the unencrypted message and the encrypted message. Right now they're just blank. And then we're going to move down here to step 1.5. So this is lines 26 through 35. Or 30, yeah, through 35. I'm going to uncomment those out as well. And these are just methods to help us set the key. So when you pick a key in the dropdown, and how to set the message. So as I type a message, we're going to want to set the message. Now you'll notice that I have some red squigglies underneath here because I'm trying to call a method called execute encryption, but I haven't uncommented that out yet. So you'll see here in my console, I have a bunch of errors because it's trying to call something that doesn't exist yet. So we need to fix that. So we need to uncomment out in step 1.6 the execute encryption method. So this one's a little tricky. We're going to uncomment out 37 through 40. And then we're also going to uncomment out 46 through 70. And then we need to do one more thing. So this is our encryption method, and we need to display the encrypted value. So in the last step of part 1, we're going to uncomment out 33 and 34 in the view. So now we can encrypt our message. So I'm going to type my message. And my shift key is 0, which means I'm not shifting it at all. So the encrypted message is exactly the same. Now Caesar always used 3. So when I change this key to 3, now the message is encrypted. So whenever Caesar would send his message, he would write it out, and then he'd run it through his algorithm manually, shifting every letter over by 3, and he would actually send this to his generals. So let's walk through the logic of that, because it seems pretty straightforward, but let's look at this execute Caesar shift encryption method. So the way I do this is, basically you have to loop through every character in the message, so A, N, D, Y, and for each of those characters, you apply the shift. So in this case, it's 3. So I'm going to look up A. I'm going to move 3 spots in the array, which is D, and I'm going to replace A with the letter D. And I'm just going to keep doing that. So you find the original location of the letter. You add that shift, in this case 3, right? And then you start writing a new message. Now there is some trickiness to it. So the first tricky part was what happens if I'm adding 3 to, say, a letter at the end. So say I'm adding 3 to Z, I now need to wrap back around to the beginning of the alphabet, to the beginning of the array. So here you'll see that if after I've added my shift, which is the new index, if it's greater than 26, I actually subtract 26, and that will put me back at the beginning of the array. So that'll help me wrap around. And then there's also a special case here is if there's a space, I just want to skip over it. So if the letter cannot be found in this array of 26 characters, I just add a space to it, and that way we just skip it. So you'll see here that my encoded message is being shifted. And if you change the shift key, it will re-encode it, right? So Caesar used 3, but you could really use any key you wanted up to 25. And you see that it's re-encoding the message. So that's the Caesar shift. Now you can see that the Caesar shift itself seemed like a pretty easy encryption method. You're just shifting. You only have 26 characters. You're shifting it some number between 1 and 25. But then I also had to account for the wrapping around and the spaces. So even writing this simple algorithm took me a little bit of time to test and make sure that it worked correctly. So in modern times, we do not write these encryption algorithms by hand anymore. We don't write them custom. All of those bodies that make up the encryption standards that I talked about during the presentation, they publish those, and then people write libraries that you can import in your projects so you can use those standards of encryption. So the first one we're going to look at is AES. Now you'll see that in my model file here, my TS file, I'm importing something called crypto.js. What that is that's a library that has been built with all of those encryption standards in it, and it's easy to implement them. So we are going to implement AES. So to implement AES, this is part 2. We're going to start here at step 2.1, and we're going to uncomment out 21 and 22. Okay. Then that's just the encrypted and decrypted messages. Those are empty for now. Now we're also going to uncomment out 42 and 43. And what these methods are doing is you'll see that I'm calling an encrypt with AES and a decrypt with AES method. Now again, I'm getting some errors because I haven't uncommented out those two methods. They're down here. So you're going to want to uncomment out lines 73 through 81. Now again, AES is the symmetric encryption. So what that means is it needs a key, just like Caesar Shift. So I wrote a secret key here. I just used every mascot that I've through high school, college, wherever I went. I was a Blue Streak in high school, a Laker at Lakeland, a Golden Flash at Kent, and a Viking at CSU. So that is the secret key. Again, this is two-way encryption. You have to have a secret key. So what happens with the secret key is when you encrypt with AES, you have to pass the message that you're encrypting and what you want the secret key to, what the secret key is. And then when you decrypt, the same thing. You pass the encrypted value and the secret key to decrypt it. So let's go back to the view and we can display the AES encryption. So you're going to want to uncomment out 37 through 42. So at this point, I don't have a message, and AES is just going to encrypt whatever I type in here. So again, I'm going to type Andy is a dev. And you can see here that AES is encrypting it with this secret key to this random string or this random sequence of characters, right? And this is the power of encryption. So this would be stored. This is what would be sent encrypted. The only people who could unencrypt it would be someone with the secret key, and if they knew what algorithm that was used. So that's the powerfulness of the two-way encrypted. You could brute force this and somehow turn this random string of characters back into this decrypted message, but that would be nearly impossible without knowing which encryption method was used and which key was used. So that's AES encrypted, and that's pretty powerful for the symmetric encryption. And then the last thing we're going to do is we're going to look at hashing. So again, I talked about hashing is used throughout the software development industry for hashing of messages to store in databases. So the first thing we're going to do, we're looking at step 3.1. We're going to uncomment out line 24. We're going to uncomment out line 45. Okay. Now you'll notice here that hashing is one way and there's no key needed. So you'll see here that I don't have a decrypted version of the message like I do with Caesar Shift or AES. That's because it's only one way. It only gets hashed and stored. So we have to do one more comment out in this model file, which is line 84 through 86. Right? And you'll see here that when I encrypt with SHA, I'm not passing it a key like I am with AES or with Caesar Shift. That's because it's just running the algorithm. There is no key. It's just hashing that value. So if we go back to the model, and we're going to do our last uncommented out, line 45 and 46, you'll see that this heading shows up for the SHA encrypted message. So this is an example that you would use for like a password. So you'd want to hash it and store it in the database. So if I type in password, right, you'll see that the hashing has turned that password or the text of password into this value, right? Now you'll notice that, and the other thing about the SHA is that the same message always ends up with the same hash. So here this hash ends in AD. If we clear that out, we type something else, then we go back and type password again, it should end in AD, and it does. So that's the power of hashing, is the same message ran through the same algorithm will always lead to the same encrypted message. And that way you can compare passwords, you can compare any values without actually unencrypting them. You can just compare their hashes to make sure that the message is the same. All right, so that's it for the hands-on. Again, we looked at AES, we looked at Caesar shift, and we looked at hashing. So I'm going to go back to the presentation, and we can wrap up. So just to tie a bow on everything we looked at today, Angular, we use that for the two-way data binding. You saw that the model and the view, it's easy to pass a value from code into the user interface and vice versa. And we used Angular to do that. We saw style guide. So you saw how I implemented some of the CSS classes from the US WDS into our little application there to style the inputs. We talked about encryption. So we looked at one of the oldest algorithms, which is the Caesar shift, which was pretty basic. And then we looked at some modern ones like the symmetric, which is that AES we looked at. We talked about public key, and we also talked about hashing or one-way encryption. So that's all I had. That's the end of my slideshow. So I will go ahead and stop sharing.
Thank you so much, Andy, for that awesome presentation on encryption. I found that extremely interesting. It's a topic that I don't know a lot about, so I really enjoyed learning some more about that. Students, we are now going to move on to our Kahoot portion of today's and Q&A portion of today's kind of event. In our Kahoot, if you remember, there will be some pre-populated questions that you'll be able to choose from to ask Andy. But if you have any specific questions on his career path or today's activity, you can go ahead and place those in the chat and we will ask those as well. But I'm going to go ahead and get ready to share my screen. We'll be moving into our Q&A portion. So this will be a couple of those pre-populated questions that you might want to ask Andy. And the questions are, what do you enjoy most about your job? What was your major in college? What advice would you give to someone interested in entering this field? And again, what was your major in college? Okay, so it seems that the most popular question to ask is, what advice would you give to someone interested in entering this field?
Oh, that's a good question. So software development, like I tried to explain in the presentation, is a wide variety of jobs, right? So as software has become more ubiquitous in our life and everyone has a cell phone and a website and uses computers from day to day, there's no longer the idea of just a single software developer who knows everything. So I'm more of a front-end developer. I excel on that side. There are people who write databases or work on databases. There are people who write business logic. So really, to be interested in this field, you really have to understand logic and programming. Now, going to college and getting a computer science degree is probably the easiest way to get that background in logic and programming, the skills you would need to be in an app development role. But there are other ways as well. There are boot camps. There's a lot of stuff on the internet, just free courses. A lot of the learning that I have done, I taught myself Angular 3 or actually probably 5 or 6 years ago just by watching YouTube videos. So really you have to be willing, you just have to be curious, and you have to be willing to go out and find stuff. You can find stuff that's free that's just as valuable as going to college, but really either way is a good way. It could be easier to get into development if you have some kind of formal degree, but there's a lot of resources out there.
And then Andy, could you remind students what your majors were in college and how you kind of did that shift between your undergrad to the job you currently have?
Sure. My bachelor's degree is in integrated mathematics. So what that means is math and education combined. So I basically double majored in math and education. And now I have a master's degree in computer science. So I was able to turn my math degree into the computer science because they're both kind of logical disciplines. So they kind of overlap a little bit, math and computer science.
And in between your undergrad and your master's, am I remembering correct that you went and got a certificate kind of in this field as well?
Yeah, I went to Lakeland and they have just it's basically it's a programming certificate. So it's like 10 classes and they are just a variety of programming languages. So really you could get that certificate with basically an associate's degree. I think it was the minimum. So if you had like a 2-year degree from Lakeland and then you got their certificate, you could get into the industry. And Lakeland was very affordable, which is why I chose it.
Thank you. Okay, so we're going to move on to our second set of questions. So this will be another set of questions that you can choose from to ask Andy. So the questions are, what has been your experience in a STEM field? Would you choose the same career if you had to do it all over again? Did you always want to work in this field? And what piece of advice would you give to yourself while in high school? Let's go ahead and choose from those questions. Okay, so it seems to be our top question is, would you choose the same career if you had to do it all over again?
Yeah, I would. I would say obviously I switched from teaching to come back to software development. So I think that in my heart, I always wanted to be a software developer. I would not change the way that I got here though. Like going through the route of teaching first showed me actually how difficult teaching can be, and it gave me a lot of skills that other developers don't have. Like I'm more comfortable speaking in front of groups of people than a common developer, and that's because I had to when I taught. So it gave me a respect for teachers. It gave me a respect for continuing learning my whole life. And then I was able to take that and go back to software development and apply those teaching principles also in my development career.
And then since we have some time, I'm going to go ahead and ask the second highest rated question is, what has been your experience in a STEM field?
Well, I mean, obviously I was a math teacher and now I'm computer science. So I spent my whole career in STEM fields, basically. I love solving problems, and that's where the math and the technology comes from. When you're a software developer, you really spend all of your time trying to solve problems efficiently as possible. And that's just what I loved about math. It's what I loved about computer science. So that's really what my experience has been.
Wonderful, thank you. And if you have any personalized questions for Andy, either on his presentation or his career path, feel free to put those in the chat and we will answer those as well. Okay, so we'll move forward to our next question. So the next question is, which is not an encryption key? Hash function, public key, private key, symmetric key. So think about those keys that we discussed in our presentation. Okay, it was the private key. We went through hash function, we went through symmetric, and then also in the presentation we talked about public key. Okay. Next question is, which website is written in Angular? Andy gave us some examples of websites that use Angular. Is it Instagram, Xbox, PlayStation, or Netflix? It is Xbox. So he gave us an example of a couple websites that are written in Angular, as well as Google is written in Angular, Xbox, NBA. But Instagram, PlayStation, and Netflix all come from other software platforms. Okay, and this is going back to style guides. Why is style guiding important for coding? Think about that first thing that Andy was talking about before he got into the different types of style guides. Is it because it details various elements and patterns for a site or application? Because all style guides are the same? Oh, okay. So the majority of the class answered it correct. It's because it details various elements and patterns of a site or application. You can use different style guides, and depending on those style guides, the style guide will give you the different patterns and elements that you need for that website or application. Very good. Well, thank you so much for joining us this morning. We hope you enjoyed our session on encryption. Our next session will be taking place on February 4th at 11 a.m. and that session will focus on statistics and analysis. So mark your calendars and keep that in mind that February 4th is our next session on statistics and analysis. But have a great day, everyone. Thanks for joining us.
Thank you.